Inverter performance is the most important driver of solar project profitability. Today on the Solar Podcast, PV Inverter and Storage Reliability. Welcome to the Solar Podcast. I'm Tim Montague, your host. My guest today is Michael MillsPrice, Head of Inverters and Storage for PV Evolution Labs. Welcome to the show, Michael.
Thanks, Tim. Thanks for having me on.
Really appreciate you coming on the show. PV Evolution Labs is making a name for itself in the solar and storage industries. But before we dive into the core topic today, would you please introduce yourself and tell our audience how you got interested in renewable energy?
Yeah, so Michael MillsPrice. Again, I'm the head of inverter and energy storage business for PVEL. I started in the solar industry in 2004 with a small inverter company in Bend, Oregon called PV Powered. I was the first electrical engineer for PV Powered. It's been a number of years developing products for the solar market, and we grew that company as a US-based manufacturer, and then were purchased by Advanced Energy in the early 2010s. And I stayed on with that group and led the technology division for a few years, and then joined PV Evolution Labs. At the time, Jinya Maidbray was the CEO, and he had reached out asking if we could create a parallel business to what they were doing with PV modules, focusing on performance and reliability of these solar components, and brought me under his wing, and we created the inverter business and then subsequently the storage business for PV Evolution Labs. So been in the market for about 20 years, almost 15 years.
Impressive. You are what I call a solar OG. So it's great to be in your midst. And so let's talk a little bit generally about inverter reliability. We're going to spend the bulk of today focused on the inverter scorecard. It's an established routine for PVEL, so to speak, and then we're going to spend about 15 minutes, hopefully, on the storage piece. So stay tuned for that. But let's just talk generally. What is the inverter reliability scorecard, and why should viewers go to pvel.com and download that report?
Yeah, so at a high level, the inverter scorecard is really a culmination and a high level summary of our testing results on those inverter products. So PVEL performs a number of detailed tests, both performance and reliability, on any given inverter product. And then the scorecard allows us to compare those manufacturer to manufacturer, or even across different platforms, 3-phase versus single phase, or microinverter versus optimizer. The goal really with the scorecard is to help educate the community. It's to help buyers understand different things with the product that could differentiate them in terms of the final installation location, or how they would, we would expect them to perform once fielded. I would add that the scorecard really does provide additional educational context around certain functions and features that you may see in data sheets, and allow you to really understand what those individual functions do, and then how specific products perform relative to their peers.
Sure. And who is your primary audience?
Yeah, our primary audience is the buy side of the solar and really storage market. So you're talking about the developers, the buyers, and then on the investment side as well, the banks that might pick up portfolios, or the insurance firms that are backing certain economic functions. So really it's the buy side of the world that is our primary target audience for the inverter scorecard.
Yep. And that means that these products are available to the buying public, to EPCs, installers, financiers. So don't hesitate to go to PVEL and check out this content. And I will share a little later on in the show the 2019 scorecard. So how does PVEL pay for this, this work, and share with our audience some of the details of what that entails, maybe from start to finish, how, once a product rolls in the door, so to speak, how long does it take you to conduct your testing?
Yeah, so maybe one step above that, if we think back to the, 2012, 2013, we had manufacturers both on the module and the inverter side who were looking to get into some of these larger developers approved vendors lists. And each developer end asset owner might have had a different set of criteria, which means a different test regime really for that particular inverter manufacturer. And what we did was we pooled the buy side of the world and said, what's important to you? What are you seeing in terms of field failures? And created this inverter product qualification program to encompass most of their pain points. So if a manufacturer was to come and test through the PQP, they could take those results to a host of different developers and hopefully get on that approved vendors list, depending on the results, of course. And so really we find it to be market opening from a manufacturer perspective, because these tests are those ones being required, mandated, or at least recommended by this large pool of end asset owners. When it comes to cost, the contract typically goes with the manufacturer. So they're paying us directly, and then they're sharing those results broadly with our entire list of downstream partners. And again, those are the developers, financiers, EPCs, those folks. So it's a direct relationship contract-wise with the manufacturer, but then the results can be disseminated amongst, folks who are buying 30 plus gigawatts of solar when you pull them together over the course of 2020 or beyond. Did that help answer the question a bit, Tim?
Yes, definitely. So how does a manufacturer engage in the program?
Yeah, so the manufacturer would reach out to our team and send us the product level details. So for a new inverter type model, and we typically see a cadence of about 18 to 24 months, product release to product release. They've made a bunch of improvements based on field history and where the market's going in terms of technology. So they reach out to PVEL, to myself, and we create a contract with them that matches up with that product and the PQP's stage at that point in time. Because the product qualification program is an evolving process. It's static, but if we find new field failure modes, or as we add new functionality to PV inverters, which we've actually mandated quite a bit over the last 10 years, we want to make sure that we're testing that new functionality and providing a description of that in the technical report, and then following that into the scorecard.
Sure. In the solar industry, there's at least two kind of standards bodies. There's UL, Underwriters Laboratories, and there's SunSpec.
Yep.
And then you are a kind of third universe. How do those three worlds interact, and how do you figure out what are the key criteria to be testing and evolving your program to meet, so to speak?
No, this is a great point. So the UL piece of it, the certification testing is to allow a product to safely be interconnected. So the primary function of those UL tests, 1741 for the US market, and it encompasses the IEEE spec 1547, is to ensure that the product is safe, that it interacts with the grid in a way that if the grid goes down, the device trips offline, so line workers, utility folks can work on that fault and get it up and running in a safe environment. It does not directly provide any information on performance or reliability. So the 1741 certification is not intended to show the performance of a product, how much energy it might harvest over its life, how long it might last once installed. Similarly, the SunSpec work is really around the communications interface. So there are these different functions and features we require of inverters, whether they be low voltage ride through or some kind of reduced power throttling if there's a frequency event. And the SunSpec Alliance covers that interface between the inverter and the external device, telling it what to do. Again, not focused on performance or reliability, but basically an ACK-NACK response. Do this if you're told to, and do it over this communication interface. And where we fit in is providing that third-party independent data around performance and around reliability. So is it likely this product will last 10 years? That's the type of things we're trying to answer as part of the product qualification program, which is quite a bit different, and I think synergistic with the other UL and SunSpec compliance items you mentioned.
Great. So it's a both and world, right? We have to be informed about what's going on with SunSpec, although participation in SunSpec is not required, and I'm learning that it's hit and miss. Some manufacturers are in, some are out, and it is, especially around communication, I think somewhat of the Wild West still. It's certainly a bit of the Wild West when it comes to rapid shutdown, even though there are some clear guidelines exactly how you achieve that is really up to the individual designers and engineers.
Right.
So how do you as PVEL stay on top of the inverter industry?
Yeah, the biggest thing for us is continuously looking at new technology as well as existing technology. And then getting feedback. I keep mentioning these downstream partners, these developers, these project and asset owners, financial institutions. So we get annual feedback, even more often than that. But annually, we have a steering committee review of our test practices. And at that review, we also ask or submit for new field failure information. And so what we're getting is a refinement of the current test processes and outputs, and ensuring those are aligned with the most recent field failures that we're seeing at the fleet level or even at the industry level. So if there's a new mandate for RSD, a few years back, we wanted to get out in front of that and begin testing these rapid shutdown products prior to them being mass deployed. And the idea there was to help reduce risk of false tripping, nuisance tripping, these types of things, or failure to performance function before you have millions of these things installed. And so it's that constant feedback cycle with the folks that are operating and owning the sites and our core research team at PVEL who's performing the tests to help ensure that we're steering the PQP in a way that meets the industry's needs in somewhat real time.
Yeah, and we're going to dive deeper into the PQP. So, well, let's be clear, because I get confused myself. The PQP is the product qualification program. That is the heart of the scorecard, right?
That's right. So the product qualification program has a number of individual tests. And then the scorecard is a high-level summary of how different manufacturers performed relative to those tests.
And for an installer to really get under the covers, they have to become a member of a program. And what is that program?
Oh, right. So anyone can sign up to be a downstream partner, as we call it. And what that does is gives you access to those specific test reports. So the scorecard is a high-level summary, as I mentioned. If you want the detailed test report of specific manufacturer to the product qualification program, you sign up to be a downstream partner. And that gives you access not only to our inverter technical test reports, but all of our PV module test reports and our storage test reports. And so you really get this breadth of access to a lot of different individual products, all the way to the BOM level for PV modules or model level for PV inverters. And that's through signing up to be a downstream partner.
Thank you.
Yeah.
So yeah, I myself have just recently become a member of the downstream partner program, and haven't had a chance to really get into the weeds yet. So I'm learning as I go about that program, and but so far I very much appreciate that program and encourage other installers and EPCs to dive in. There's no cost to the EPC or the installer to participate in that program. It's simply it's a gate, it's an access point. So don't be intimidated by that.
Yeah.
And so let's take a little tour of the scorecard. I'm going to share my screen here and show our audience the 2019 scorecard. You'll have a new scorecard coming out in 2021, I believe.
That's correct. Yeah. We have been working on our 2021 scorecard and are trying to align it with, roughly that product development cycle I had mentioned, this 18 to 24 months roughly between individual products being released by manufacturer for the same power class. And so 2021 is our targeted release for the next inverter scorecard.
Great. So where would you like to start? Methodology, test results?
I'm happy to jump in, right from the beginning. I think, some of the things you learn from the scorecard are how many actually pass or fail different test legs. We find that 20% of products, fail passive chamber tests, as an example. or that, 1/3 can't detect a real arc fault if it's inside the array. So we can talk to any individual piece of the scorecard, and I'm happy to walk through a couple examples in there. Open to where you want to start, Tim.
Cool. And I want to encourage the audience to ask questions. You can use the Q&A function here in Zoom to ask questions of Michael. And yeah, so one of the cool things about the report and the scorecard is that it gives a nice introduction to what are the basic functions of inverters and what are the components in relation to the array. I'm not going to bore our audience who's generally quite familiar with these things, but if you have customers who are wanting to really understand more about inverters, this is a great introduction to inverters. And then there's a nice table, which I will share here in a second as well, common types of inverter failures. So why don't we talk about that? It starts with out of the box. And surprisingly, we do have out of the box failures. You would think that would be like a non-existent thing. You would think that they would have to have passed some tests at the factory. I guess the damage could occur in shipping, but yeah, let's talk about inverter failures. How do they fail?
If you pull that back up, Tim, that table. So as you mentioned, all inverters actually do get tested, or supposed to get tested, as part of the production line sequence tests prior to shipping from the factory. But things can happen, right? If someone doesn't have their static bracelet on and they happen to touch the wrong component or board as it's getting packaged up to go out the door, certainly that can result in a failure. And what we found at PVEL, and working in conjunction with our DSPs, was there was a real lack of the capability to classify different inverter failures before we had released this. So an inverter failure wasn't just binary. There are certain things that happen that could limit power output, as an example, or cause nuisance tripping, which would limit your total energy output, as an example. And then there are the more binary catastrophic failures, right? When the IGBT stack blows and the inverter is down and there's some, charred material inside, or you have some significant component failure or wear out. In my mind, I'd think of DC bus capacitor. But what we wanted to do with this was set context so that when we're talking about inverter failures, broadly as an industry or directly, client to us, we could rank them in certain cases and then really show what they ended up causing. So this kind of cause and effect. Is it production loss? Is it total replacement O&M style? Or is it something nuisance where, we need to either relax the capabilities of the device to trip thresholds to allow it to provide that energy harvest over a longer period of time. So just setting up a way and a means for us to communicate about different types of inverter failures and really what their impacts are. And that was the intent of that classification system.
Okay. And then there's a nice table on PVEL's PQP tests, passive chamber testing, thermal performance characterization. Let's walk through that.
Yeah. So again, we're performing lab tests and we're trying to do it in a commercial practice. So we have to do accelerated aging tests if we're going to try to project how long the product will last. So we're intentionally putting it in conditions that are, at the maximum end of the ambient temperature window, or even above that for some of these tests. So what you see in this table on the left side, passive chamber tests. What we do with these tests are we electrically pre-characterize the inverter. We run the inverter through a number of electrical tests prior to exposing it to damp heat, thermal cycling, or humidity freeze. Following that exposure, we then post-characterize the inverter. We run it again electrically, and we compare the post versus the pre-electrical data to see if there's been any kind of degradation or any failures as a function of this electrical health signals, which could be anything from DC bus ripple to lots of harmonic output as a function of operating or failure. If we jump into the next column, the thermal performance characterization, these are powered environmental tests. And so for each of these tests, we're actively collecting data as we're exposing the device to high and low temperature or large swings in temperature, and really evaluating the capability of the device to operate under those. On the right side, really from the two performance test categories, we document the capability of the device to harvest energy. And that comes through a product of the max power point tracking efficiency and the conversion efficiency. We test the operational bounds, and really what we're trying to understand is, does the product derate power output as a function of AC AC output voltage or DC input voltage? Are there certain things that cause this inverter to derate? Finally, we do install the product in our field site at PVUSA as part of our product qualification program. There are things that frankly you just can't learn in a lab environment that definitely show up in a fielded environment. So it's a really critical piece to our product qualification program is to also install the inverter in our research facility and allow it to operate from solar for 30-day runtime while we expose it to ground and or arc fault events. So combined, it's a pretty large test program, but it really allows us to put the inverter product through a number of paces, to validate datasheet claims, and to understand the design in terms of resiliency and reliability.
So at the end of the day, you're collecting a bunch of information about reliability and performance. How should installers and EPCs and developers use your results?
Yeah, so some of it's situational. Like as an example, if we have certain products that can operate at a higher temperature, higher sustained temperature really, at full power continuously, and they're going to be installing them in a desert type environment, it makes a selection criteria much simpler, where if other products significantly derate power output above 45C as an example, that may be something to avoid. So there's certain categories of our test results that you could use as a developer to quickly select a product that's going to produce more energy for you. In other cases, there's some competing things, whereas you might have specific needs to have a very high DC loading ratio, where you're installing a lot more solar PV relative to the AC output, nameplate output rather, of the device. This was common in the Northeast for a number of years. And there are certain products that perform much better with high DC load ratios and others that frankly are voiding the warranty, or you may have premature failure. And so there's some categories that are very black and white in terms of product selection, and there's others that are more installation level specific. And those test results are highlighted in the technical test report. And certainly if you're reading a report, you can reach out to us at PVEL and say, hey, here's my application. How does this product fit? Or would you recommend another product? And we're here to help support that.
Yep. One of the things that I appreciate about this summary, and I do want to remind the audience that this is just the summary. Okay. So the scorecard is the summary of results. To get under the covers and to get much more granularity of these test results, you simply become a member of the Downstream Partner Program.
That's right.
And, but for example, here you see a summary of MPPT efficiency, conversion efficiency, and energy harvest. And then it lists out some top performers. And so you can, at a very high level, get a sense of, okay, some of the brands that we're working with are here or not here. And that may, honestly, that was a wake-up call. When I first learned about your scorecards, I think the module scorecard was the first that I really took a deep dive into. You quickly get a sense of, are you working with some high quality product or products that are, problematic?
Yeah, we found that, as another just practical case, the maximum PowerPoint tracking efficiency for different products. I mean, this is something that if you're doing O&D files and PVSYST, we're always assuming this 99+% maximum PowerPoint tracking efficiency. And this is the algorithm for the listeners that's responsible for keeping the array at max PowerPoint with different changes in irradiance and temperature throughout the day. And we show that there is a broad difference across the industry in terms of their ability for that internal algorithm to maintain that max PowerPoint and really leave energy on the array. So it's one particular function that we've seen a very broad performance category for with today's solar inverters.
One of the listeners asks, how can a company join the Downstream Partner Program? And that's a good question, because it's not immediately obvious on your website where to go.
Oh, okay. I can help map that back out and send it back to the audience afterwards. But yes, you can do it on the website, how to sign up for a DSP. And if you find that troubling, you can send me a direct email. I think we'll have my email posted at the end of this, and I will connect you with Adam internally, who will help set you up as a DSP. And effectively, it's an NDA with PVEL, and then there's a couple other criteria as part of that. But it's really straightforward and no cost, as Tim mentioned.
Great. So please, audience, get your questions in. This is a great opportunity to talk directly to Michael MillsPrice, who is the head of Inverters and Storage at PVEL. He's also a professional engineer and a solar OG. So Michael, tell us about the future, and we're going to also bring in the storage topic here pretty quickly, but what is going to be new in the 2021 report, the scorecard, excuse me?
Yeah, so I think, and maybe even just one step back again, we've starting to collect a lot of data, not just PVEL, but the industry as a whole on fleet performance. And I think one thing that continues to shine year after year is the number one source of really PV system underperformance can be linked back to inverters, right? It's the number one in terms of O&M tickets. And it really is one of the risk factors associated with meeting your economic portfolio performance goals. And so continuing to understand both the failure modes that we talked about earlier, but really what's their impact on my fleet performance? You know, we're seeing lots of systems in that 6 to 10% underperformance over the last 4 years, and that has to be explained. So for 2021 scorecard, we are continuing to focus on the functions and features that could limit inverter output at the system level. So we really understand what's happening at the system level, not just at the individual device level. And then really tying this back to some of the new features and functions that are being invoked by products. So, you know, with the mandate of IEEE 1547.1a, we see products that are supposed to ride through lower voltage ride-throughs for extended periods of time and have some other functionality, really this volt bar functionality. If there is a grid event, how do we respond to that? And how do these solar inverters actually help keep the grid alive as opposed to trip offline, which was historically how solar inverters as part of the DG world were asked to do. So a lot of our new pieces to the scorecard in 2021, beyond the 1500 volt inverter testing that we do, and extending the 1000 volt as well, is really around those functions and features that are somewhat new to the market in the last 2 to 3 years, and how those may impact total energy harvest over the life of the system.
It occurs, and this is a question from an anonymous listener to me, that some manufacturers have a dizzying array of product. And do you have some specific criteria for what inverters you're going to test? What, you know, let's just talk about string inverters.
Yeah.
They come in a million different flavors. How do you handle that?
Yeah, they do. So there's 3 primary DC voltage classes we test. 600 volt for legacy rooftop, 1000 volt, kind of the C&I market, you know, larger string inverters, and then 1500 volt, which are, you know, kind of the latest inverters that are trying to address that small utility market or even full utility market. So we break it by DC voltage. And then inside of that, product manufacturers are designing their inverter products for what they think the buy side of the world wants. So for us, we test products based on the hardware, so the bill of materials of the inverter and the firmware. If there is a product that covers 2 power classes, 50 or 60 kilowatts or 100/75 kilowatts, but the hardware is the same and they're using the software to limit that functionality, we typically would test one of those and then write the report for both, because the hardware is symmetric. And then we would test the one that's being pushed the hardest in terms of the silicon utilization. So if it's a higher current product, we would pick that one over the smaller one. But as far as product to product, you know, if they build a residential, a commercial type product and an industrial, there's enough differences in the hardware of those and the firmware, and frankly, even like the switching devices, that we would recommend testing at least one of all 3 if we're going to write a report for it. Because even inside of a manufacturer's design practices, we find there would be significant differences with the different classes of product as I segregated by the DC voltage input. Does that answer the question, Tim?
Yep, I think so. I'm just curious that today my understanding is 1500 volt inverters are only allowed on ground mount in the United States. Is that right?
I think that's correct still today. We could see them move into rooftop applications at some point.
Mm-hmm.
It's part of what we test because of that buy side of the world really wants to understand it. One unique thing about 1500 volt is the silicon had to change quite a bit. You could basically no longer use 1700 volt silicon unless you were very clever with it, and certainly not 1200 volt silicon. And so some of the topologies associated with switching at 1500 volts had to change. Maybe if it went to a 3-level inverter, or if it went again to the higher voltage silicon components, which is quite a difference in terms of hardware if you're on the power electronics side.
Yep. And we have another question about inverters with optimizers.
Yeah.
So there's, again, a growing ecosystem of module level power electronics and other related devices. But so how do you test those combinations of inverters with optimizers?
Yeah, so we certainly do. We test inverters with optimizers. We test standalone optimizers and standalone inverters if they are some kind of agnostic hardware device. The optimizer is basically an inverter, but just outputs DC. And so our test approach for microinverter or optimizer is almost the same. Again, you wouldn't be talking about conversion efficiency to AC, but you'd still have a DC input to DC output conversion efficiency. Much of our reliability tests are very much the same. In some cases, the module level electronics are exposed to longer durations and higher temperatures for the reliability tests, because again, they're going to be mounted on the back of a module, and it really is a different installation class if you think about their install location than our string inverters. But our approach is to continue to, one, stay tight with standards like the IEC 62093, and then apply those stress factors to the optimizers and or microinverters in line with their exposure category. We do test the optimizers, again, tied with our inverter as well, to ensure that interoperability and understand any of the technical complications when they're paired together. But that's pretty straightforward from our standpoint in regards to performance and reliability testing.
Okay.
Yeah.
Well, before we segue into storage, is there anything else you'd like our audience to know about the Inverter Scorecard or the PQP program?
Yeah, I mean, we use, so I mentioned this Downstream partner network, and we'll follow up on exactly how to get signed up for that. But we do use your influence, right? If you're reading this scorecard or reading these individual technical inverter reports, which is scorecard gets you to do, help push manufacturers in there. I mean, that's the whole idea, is to create a world where better products are installed in the solar industry, in the US market specifically. And to do that, what we want to do is have this independent testing and feedback cycle so that we're capturing your biggest pain points, including those in the test regime. And then manufacturers, as a function of coming through the testing, actually learn quite a bit about their products and then can make those relevant changes and get better products to market. What we're hoping for is products that meet their warranty period or beyond and continue to harvest the most amount of energy over their installation lifetime. That's really our goal, right? To create better products for our solar market in line with including your feedback and the manufacturer's improvements to their existing product line.
And when a manufacturer participates in the program, which is completely voluntary, right? There's no third party forcing anybody to participate in the PVEL program. But when they do that, what is the nature of the feedback besides the test results that you're giving to the manufacturers? Is it any different than what the downstream partners are seeing?
Yeah, so the contract is generally with the manufacturers, and so they get to be a part of the testing program, at least, reviewing that data throughout the entire test process. Whereas the downstream partner wouldn't see any test data until the final report. So they're not getting that intrinsic feedback cycle that you get when you're evaluating a product and asking questions, ensuring that the results match up with what was intended.
But so you're effectively functioning as a third party test lab also for the manufacturers, right? Where if they want to run certain protocols, you will potentially offer that service.
Yeah, we'll help them evaluate their product and really benchmark it relative to others in the industry. Absolutely.
Yeah. And is there anyone else in the world that's doing exactly what PVEL is doing here?
So I think there's people in the world that are doing pieces of what we do, but but not end to end. I think we're really providing a unique service, again, focused really on reliability and performance, some safety tests or spot checks outside of that. But really what we're trying to do is help that buy side understand the products they're going to be buying. And I don't know that we have a direct competitor today, although there are some labs that offer pieces of the testing, component level or subsystem level, but I'm not aware of anyone that's offering the same product qualification program end to end.
Yeah. Cool. So another anonymous question here. If a manufacturer pays you to review their product, can they ask you to withhold the information if it's not positive?
So it is up to the manufacturer to allow us to share the results with the DSPs. And this has been true from the beginning, right? They're the contract holder. If they see a specific result that shows their product is really underperforming, they don't have to share that report as part of our downstream partner network. Typically what it results in though, is them to fix the problem and resubmit for testing because it's been identified at that point. And a lot of our downstream partners, although it's not required in quotes, if you want to get onto that approved vendors list, you will come through and get a test report. And so if they did find a major product defect, to finish that thought, they would fix the product defect and come back through the testing cycle so they can get that technical report.
So there is some flexibility there for the
There is.
manufacturers.
Yep.
And then another question, do you receive feedback from developers or installers about their practical experience with inverters and how they're performing in the field?
Absolutely. That's integral to our whole feedback cycle. We really, really love getting the field data, even if they can't share it or have to share it anonymously. Those points are exactly how we help steer our forward-looking test strategy. So if we're seeing inverters that are underperforming 5% in terms of output power, we can identify the string length. Is it a low DC voltage condition that's causing this inverter to limit, or is it some other factor? Those are exactly the types of things that our steering committee looks at to help shape the next set of tests for the next calendar year. And they don't really, the tests don't change like by a lot, but certainly with new functions and features coming in or underperformance identified, it certainly helps in our feedback cycle.
And how do you solicit that feedback?
So, a lot of my daily job is talking with the downstream community and understanding what their pain points are. And certainly reach out to me directly or jump on our website and send us feedback as well. If you are a DSP, you can leave that feedback in the portal as well. This is your access point to all those technical reports. There's a number of different ways we can solicit that feedback.
Okay, great. Well, let's segue to storage. And maybe we can spend 10 or 15 minutes on storage. As all of our viewers know, storage is, quickly gaining traction, especially in certain markets like California, Hawaii, New York, Massachusetts, even here in the Midwest in Illinois. We're doing a fair number of storage projects now. And, the projections are that storage is going to be a major growth opportunity here for solar, wind, and storage. And obviously, well, for those who don't understand, storage is the holy grail for renewables because it allows you to offer services to the grid or to the facility when the sun isn't shining or the wind isn't blowing. And we also have a plethora of energy. The sun gives us 10,000 times as much energy as society could use. And so being able to store that energy with batteries is front and center. And that's a major challenge and opportunity. But tell us what's going on with storage and PVEL.
Yeah, so really in line with what we do with PV modules and what we do with inverters, we are helping the buy side of the industry really understand performance and reliability expectations of stationary energy storage. So on the storage side, we work up from the cell level. So we have to understand how the energy storage cells degrade. And these could be, little cylindrical cells like the size of a AA battery, up through pouches or prismatic cells that contain hundreds of amp hours of available energy. So what PVEL does is we perform a number of cell level tests to understand the degradation of cells. This takes about 6 calendar months, but really understanding how these things are going to perform as a function of charge and discharge rate, ambient operational temperature, average resting state of charge, and differential depth of discharge. You know, how deep do you take that battery down? If you think about your lead acid car battery, it has a parallel there. So we understand the degradation of the cells at the base level, and then we perform a number of system level tests. So this is when you have the cells built up into modules, stacked up into racks, which this is what you buy, a rack of batteries combined with an inverter. And we perform a number of system level tests, validating the interoperability between the battery and the inverter piece to ensure that it can meet its intended function. You mentioned California, so that brings to mind time of use profiles. Can it actually follow a calendar clock and charge and discharge in line with the local electrical AHJ and their time of use profile? Or for Hawaii, for self-supply, does it only discharge to the local residents and not into the grid, right? We want to take all that solar energy that's not being used by the house, stored on the battery, and then push it back to the local residents when the solar is no longer there. So the bulk of our testing is directly in line with performance and reliability of energy storage systems from the cell level up to the system level. And then in addition to that, we perform some safety tests for UL 9540A, where we're evaluating what happens when things go wrong, when a forklift punctures a battery system, or if the cell is overcharged, or the system rather is overcharged. What are the mitigating impacts of that? So that's really the three areas of focus that PVEL has in the energy storage market.
And thermal runaway, are you looking at that at all?
Yeah, so that's that UL 9540A piece. So we intentionally set cells, modules, units, or even full installations in the thermal runaway. And then we measure off gas and a number of other factors around that to understand, you know, is there a risk of explosion? Or how can we better design this container to move air in and out under these adverse conditions, or do sprinklers involved in the system? So there's a number of outputs that come from UL 9540A in regards to better system design and informing those first responders, those firefighters who might have to come to the site.
Got it. That whole ecosystem seems to be quite challenging just because there's so many manufacturers. How do you, how is that program going? How many manufacturers are participating today?
Yeah, so we have a number of manufacturers. And as you mentioned, it's very segmented, right? Many of the inverter manufacturers, aren't also producing the cells, or sometimes in some cases, the cell manufacturer doesn't produce the module, that somebody else is actually putting the cells together into a module, and then that module is being sold with someone else's inverter. So there is a complex landscape of this integration of different companies and exactly who owns the test boundary to ensure that it's doing its intended function. So we've tested a large number of manufacturers at cell and at the system level, and that continues to grow, right? We see more need for these residential and utility scale projects, and that has more vendors playing in that space. There are more individual manufacturers, I'd say, in that ecosystem than there are with our traditional storage, or with our traditional solar rather. And so there's a number of unique tests you want to perform around interoperability to ensure that the thing does what it's expected to do once fielded.
Okay. What else should our listeners know about either the inverter or storage scorecard? I don't really have any other questions. I'm excited to see when will the first storage scorecard be coming out?
So we don't have a target date on a storage scorecard. We continue to gather data. We continue to test, like I mentioned, a number of unique products, and really just help the buy side of the world understand the differences in product that are out there and try to pick ones that are right for their end project goals. And that's really where we're at today. Setting a scorecard for storage is something that we may do in the future in line with our marketing team. But today it's really about helping the buy side of the world pick the right products and ensuring that we do enough diligence in terms of tests, results, empirical data, and modeling to assure or better assure economic returns. That's really what we're doing today at PVEL.
Say that last piece again.
Well, we're trying to help through providing empirical data, testing, and diligence that these projects that are being cited for storage can meet those economic returns, the forecast. That's what we're doing.
Yep. Yeah, there's the energy model and the financial model, right? And then there's the actual project, how it's performing in the field. And there's inevitably a delta between those two, hopefully not a catastrophic delta. But that's why you definitely want to do as much due diligence on the front end One of the challenges that we face as EPCs and installers is that there's a race to the bottom. There's tremendous downward pressure to meet a lower price point.
That's right.
And, and so there's constant tension between quality and price. Higher quality products are just inevitably going to cost more, and vice versa. And so you just don't want to install the cheapest thing out there, because that will come back to bite you. Here at Continental, uh, we have a robust O&M division now, and are doing O&M on many different projects, not just projects that we've installed. And we see such a huge variety of quality, not only of the workmanship, but of the equipment that's used. So beware, developers and project owners, do not pursue a race to the bottom. That is not going to serve your long-term cost of energy needs. Well, I want to make a couple of announcements. All of our content is available online at cesnrg.com/videos. Here's that page. And we're bringing to you 2 of these interviews every week, as well as an episode of the Clean Power Hour. So 3 videos a week. You see here the video we launched today, Rapid Shutdown and Solar Safety with Joe Covington of IMO Fire Raptor. There's last week's Clean Power Hour with myself and John Weaver. John is a solar installer and developer and a journalist formerly with PV Magazine. Floating Solar, Chris Bartle with Seal et Terre. That's one of my more popular interviews from the recent past. But as you can see, we're covering lots of topics: solar PPAs, the Northeast market, New York, New Jersey, Massachusetts, load flexibility with Demand X, with John Powers of Extensible Energy. So please reach out to me at TG Montague on Twitter, or tmontague@cesnrg.com if you would like to contact me. And I want to thank Michael MillsPrice for coming on the show today. Thank you so much, Michael, the head of inverters and storage at PV Evolution Labs.
Yeah, thanks for having me.
Okay, well, thanks everybody. Have a great day.